Thanks very much for your time, colleagues. This is Mike Anthony at the University of Michigan, and I have the privilege of working with Dan Horon from CAD Graphics. We're dealing with a continued interest we have in trying to get our cost structure under control. We brought this issue up last week in a commenting opportunity, and we actually discussed this a little bit at our Fire Protection Monthly Teleconference. So the particular problem of fire alarm system interoperability in our industry is one that I think is characteristic of our industry because we're doing so many renovations over time that you can go through a couple technological change cycles with them. So, I recall in the early 80s that we were still putting in zone systems, and then we moved on to addressable. Now we're moving into a world in which the prospect of convergence of security and fire alarm systems is not only possible, it's actually happening. Of course, the codes that are providing minimum standards are just that, and organizations are always allowed to exceed the code, but our point of view comes from an organization that tries to lead the trade associations who support our industry, and there are about 25 of them, and trying to push them along to be engaged in these standards development processes. So I won't belabor anyone about what we actually do here, but the specifics have to do with how can we hasten the interoperability of our fire alarm systems, even as they converge with fire security systems. And then obviously from a hardware standpoint, we are looking at the prospect of wireless devices. So in a very tangible way, you can see that spending time on this is worthwhile. And because so many of these organizations are multinational, global diversified manufacturers, you'll tend to see some of the global organizations involved in standardizing them. So first I'm going to introduce Dan Horon, and I guess what I'll do, Dan, is let you, I'm going to cut over to you. You can say a little something about yourself. One last thing, though, since we brought this up, we have to know a little bit about fire alarm and smoke alarm manufacturing. And it turns out that it's a non-trivial industry. This is just what the manufacturers are doing. They're building a 1.6 billion. So that's the market for the global diversified manufacturers. That's not installation, inspection, or maintenance. And then, but the security alarm services in the U.S. is a rather remarkable business. It's about 21 billion. So we're not talking about pocket change here. It's a fairly large industry when you consider that these security systems are converging with so many other information technology systems. So with that, I'm going to let Dan talk from his expertise and passion, and I'm hopefully here, Dan, you'll tell us a little bit about yourself, and I look forward to your discussion. Go ahead.
Okay, great. Thanks, Mike. Yeah, I'll start first by giving a little bit of a background. I started 28 years ago now connecting computers to fire alarm systems when they first came out with microprocessor-based smart alarm systems. To me, the data port on there was very useful to help look up and expand on the information that was coming out of the panels. So just real quickly, it was actually 10 years in that we came up with a Windows-based product after using AutoCAD to show floor plans for 10 years. Then it was easy to add touch screens and email alerts and tying into multiple panel types. And that had come up, of course, before, but it was in about 97 when I started. I had 10 years experience working with different panels, and I thought there has to be a way to be more neutral about which type of panel was out there, get the data from it, but treat it all the same. So this PowerPoint is my standard sales, so I'll go through it real briefly, but there's a place in here I want to stop and explain the concept more. But basically back in 1987, one of the first projects was the 3M campus in the St. Paul, Minnesota area, and they had 30 buildings and 75 guards, and they basically said, we want a system that will show our guards what to do during emergencies. And working very closely with 3M, we helped them do that. A recent project last summer was to do the Department of Homeland Security headquarters near Washington, D.C. And basically the idea is to not just show a little keypad describing things in a short form format. Here the idea is show a picture. Also show maps for location. Just a few, customers that have bought it. Software companies include Microsoft, Oracle, Google, GoDaddy, Yahoo, other industry people, hospitals, and universities, of course. And one of the things about all of these customers is they have all done something that the code did not require them to do. Adding a computer to the alarm system has never been a requirement. It's not even described in the code, and there's no UL listing to tell people what and how it should work. Over the years, this is right now this is somewhat old, probably about twice as many different types of systems as are shown here have been connected. Again, because of a recent development in the last 5 years of being able to connect to many types of systems with relative ease. The NFPA codes in the 2010 started talking about other types of systems and how to integrate, and had a little table for prioritization was an example of an entry into NFPA on this. And also in the 2010 edition, they added a statement that said it shall be permitted to provide supplementary transmission.
One thing, Dan, we didn't bring out in the very beginning was that you actually are a voting member of the Protected Premises Panel. So,
yes, that's right.
I wanted to. Normally, that's what's different about this. Is not a manufacturer presentation. This is coming from somebody who's actually on the panel, who's been on there quite a while, understands all the nuances of the processes, and is in a position to typically vote on our behalf. So go ahead, Dan.
Yeah, well, I've been on the Protected Premises Committee since 2001, and technically the category that I'm in is a manufacturer because I do have a product, and actually that's how I pay for the meetings and going to all the travel and everything that it takes to be on a committee. But in a way, it's not really, to me, an agenda issue because, like I said, the codes don't really cover what I do. So it's been, for me, an opportunity to, in my own way, give back to the community. And hopefully someday the codes will address this more closely. And actually in this 2010 edition, to me, some leaps and bounds were made. And this is one of them, but I want to flip back to, there's another thing that had to do with this. Actually, two PowerPoints or two PDF files. This is from a government agency, the National Institute of Standards, that had been working for years to come up with a standard fire service interface. And they did a study after the World Trade Center collapse. And out of the 3 buildings, only the short one, Building 7, reported anything. And what it reported was this, they said. So this is not English. This is not meant for human beings to do anything.
Well, this is an old style public pull station, isn't it? You used to see these out in the street.
Yeah, well, I think, I'm not sure, this is NIST's slide, so I'm not sure what they were getting, but yeah, this kind of thing would have been potentially generated from this those old pull stations actually used to have gears in them, and they would literally generate a Morse code signal, like that would tap out where they are. But the alarm system apparently did give out something, but I'm not sure if the text you see here was from the actual alarm panel or a receiver device like that.
It's interesting, yeah. Thanks for showing that.
Yeah, so what they were pointing out is that this is the route today that happens when the building goes into alarm, a signal goes to central monitoring, who calls emergency dispatch. By the way, this is usually a phone call from a human being that does this part, and then they start calling out, and then eventually the occupant is actually notified what's happened in his own building. And NIST said we could do better by a Venn diagram combining, and what they had come up with, and I think this is a great way to illustrate it, is leave that stuff in place. If you look closely, that original line is all here, but now we're adding information. We can publish things, we can email alerts, we can really distribute information during an alarm event. And that gets back to the PowerPoint that I was showing. And so in 2010 is when it said that it shall be permitted to provide supplementary transmission. And that was as a result of NIST's proposals to NFPA 72 that they changed the code to add this in. The idea that one example they brought up was airplanes have a black box. We should be able to get more information, better information from buildings during and after emergency events. So now one of the new things in the 2016 edition that's about to be voted into official code next week, the committee already approved this edition of a drawing in the annex to actually illustrate this statement here. So this is showing a fire alarm brand X, Y, and Z connecting through Ethernet as an example, and probably these days that would be how it would be done, and then being received and digested and data consumed by different computer devices. Of course, has to be sorted and managed, but it's a heck of a lot more capable than than this, which is kind of dedicated wired today. So, Mike, do you have any questions at this point, or?
No,
Okay.
I'm pretty happy.
Right.
I suppose some comment on that figure. I've also tried to get figures installed in the National Electrical Code. It was not well received. I thought it was very clear, but the NEC tends to want to have its guidance material in a separate book. So I applaud you for being able to get a diagram. NFPA 72 is a little bit different. There's a different history to it, but yeah, to be able to show and to make optional or recommended material or guidance material to make it more visual is very helpful, I think.
Well, thanks, but I actually had to kind of work hard for that in another way. Is on the committee and on a correlating committee task group on networking, which is one of the things I noticed is that the codes haven't allowed Ethernet to be in the code, and I have a PowerPoint on that I'm going to show next week at the NFPA conference. I want to show that real quickly here today. But
well, that's a big deal. That and the wireless devices is a big deal, because even though you are casting a vote for a manufacturer, you essentially have a killer application which disrupts some of the the classical configurations of the global diversified manufacturers. So our job is here to try to work with all innovators as well as incumbents, so to say, And so that's why your vote as a manufacturer rises closer to what the user interest is. Go ahead.
Well, yeah, and in fact, I have been listening to end users have been telling me what my product should be, and they've helped me refine it for 28 years and constantly improve based on what they want. And when you have clients like 3M and Microsoft and Google, you don't skate by doing less than what they expect.
Mm-hmm. Right.
So you tend to
There's also
fulfill.
there's also something about our I'll call our occupancy class as a campus. Our students typically are more receptive. It should be fairly clear that they'll be receiving their signals in a different way. I'm thinking over their handhelds, and of course that's another discussion about how you convey mass notification through through
Well,
Twitter and elsewhere. So that's why
yeah.
your particular wireless approaches are really killer applications.
Well, and even, finally they're going to be talking about how to add regular Ethernet, hardwired Ethernet to, products into the fire alarm arena. And you know what, this slide here, this is the typical thing. The problem with hardware that is Ethernet based is that it's all isolated from ground, and the code required you to report a ground and react to a ground. So I'll just quickly go through this, that even though there is an exception for wireless and fiber, still anything with conductors had to report this ground. So at the NFPA show, I'm going to explain and show this illustration that I made to show how circuits historically have operated by having this resistor at the end of a circuit, and then so the connection was monitored that it was connected to every device, because if it could get all the way to the end and see that resistor, then it was deemed to be good. So if a short occurs, that would actually send your panel into trouble, and as an indication that that circuit was down. So here's your panel is going to trouble.
Well, look at that. I never mastered PowerPoint animation, so hats off.
Well, this is, if anybody would like to look at this, it's actually a few people have it online, and you can actually tell a lot. It's kind of simple, like the old flip card method of showing graphics and animating things, but it was a lot of fun. For the most part, I was happy to be able to illustrate to the correlating committee that I was on with NFPA. Had Wayne Moore chaired it. He's the chairman of the Mass Notification Committee for NFPA 72. And he chaired a committee where he brought together everybody that had been voicing an interest in this idea of having Ethernet. And he brought in people from the Ethernet world that had speaker systems and signage and mass notification devices, that they came to the fire alarm industry and said, hey, I have a solution for this problem that I see. And the fire alarm industry said, no way, it's Ethernet, you can't use it. So Wayne said, we have to find a way, don't care what it is, but how can we get Ethernet in the code? And so after about 3 of these meetings where everybody seemed to be on the same page and making progress, and then the next meeting we'd start at square one, I realized that the fire alarm people were not picturing what the networking guys were talking about.
Oh, they're wire guys, right?
Yeah.
They do wire.
Yeah. Yeah.
Different
So,
kind of a mindset. Unless they can't imagine signals or of any consequence running through the atmosphere.
First slide. Yeah, exactly. I mean, these first slides, what I wanted to do is I wanted to show the networking guys that what everybody is used to are these 2 wires that go throughout a building, and they've got all these devices attached to them, and that's, this ground is a big concern. because two wires touch ground and you got a short, which could set off an alarm on the older type of alarm systems, and you know, be a big problem. Now again, imagine these two wires that are, you know, here are going, you know, in many rooms and you know, possibly throughout a whole floor of a building or more. So the potential for two wires touching ground historically has been a potential problem. But as I point out on this slide, we're only requiring in the code that we are monitoring the wires. And then eventually systems became smart. So now all of a sudden every device, or all of a sudden, 20 some years ago, every device started communicating with the central control unit, and now the control unit could tell if it was talking to every device. So it reports a trouble if it's not. So again, you get your little panel in trouble. But even though this was happening, these smart systems are all reporting, and that's an obvious advantage. We only require the wires. Oops. We only require the wires to be monitored. In the backspace there. Anyway, that's just the point, is that, you know, the codes kind of miss the fact that, hey, there's a big advantage in the fact that we're talking to every device here. And that is going to be true when we do more things that are Ethernet-based or IP-based, because every point is addressable, and every endpoint actually has, you know, an address that has to be talked to. So similar to this multi-drop communication.
Oh, the Internet of Everything folks will love this.
The what?
The Internet of Everything.
Oh yeah.
We've got a whole internet.
Yeah.
We've got a whole group of called the IoT Zeitgeist. So we're putting our
cool.
putting our boots on and our umbrella, and preparing ourselves for the storm, so to say, of
well, this class N is a good pathway, and I'll go a little quicker here to you know, basically I've shown how these circuits. Now here's where I transition to. This is the proposed fire alarm pathway, and it's been not only proposed but agreed to by the committee, and I don't think there's any opposition coming up, and so I think this should be code after next week. So the idea again is that you have these endpoints, and these could be smoke detectors and speakers and so on. I'm showing over on the right side, and then another endpoint would be a panel. So the idea is that these two devices talk to each other, and now we have a new concept that's not addressed in the code, which is a data forwarding equipment. So this data forwarding equipment is your switches, or people think of them as hubs, but the interconnection points between the endpoints. So the new pathway designation and description had to take into account that there's going to be a lot of other equipment in between your panel and your smoke detectors now. So it's important to know that in an Ethernet cable, what happens here is that out of the 8 conductors we're used to seeing, actually 2 pairs are used in a transmit and a receive pair. So data packets are just transmitting back and forth like that. But what's really interesting is that every connector in every computer, your laptop, your desktop, the switches, you see rows of connectors, every single one of those plugs is isolated from ground. So this is why there was always a problem. How do we report grounds on these isolated plugs? Because every chunk of cable that you see is isolated at each end. So even though if you get a short on these specific transmit data wires, those 2, that'll short out. But going back to the idea that you have endpoints communicating and then a trouble is going to be reported, if they're not communicating, you can still monitor the integrity of that pathway. So a single ground would have no effect because each end is isolated like this. Two grounds would be a short, and that would stop communication, just like the picture of the screw showed it on the other pair. So this is a concern to a lot of people on the committee that you still could have a problem. So this galvanic isolation does protect the equipment, but it transmits in packets like this. So instead of between endpoints signals going just all the way through like it would on a pair of wires that go all the way through, these data forwarding devices actually reconstitute the signal and verify that it's as it should be with checksums and different algorithms that are pretty cool. And then it always forwards out fresh data. So it'll keep retrying until it knows that that packet is verified to be the same as was sent. And then it'll forward it on to other things that are connected to it. And these switches know how to figure out what's connected to them even. It's all pretty cool stuff. So the idea is, your two grounds, that's not going to affect anything. But here you can see again on this picture, on the left, we have only one path here. So you could ground that, and then you have no communication between your panel and all your devices. So what class N is going to do is going to say that you have to have an alternate path. And then you won't have to report grounds on any of it. Because no ground is going to be a potential problem anymore because you have an alternate path around it.
Interesting.
So that's how we did it. That's how we got it, the code to accept Ethernet. And the committee approved everything. And going back to the diagram, I appreciate you saying that.
It's permissive now, right?
Yeah.
It's permissive.
Well, what happened is, when this code comes out, you'll see that there are actually about 6 diagrams in there illustrating class N.
Okay.
Well, since I was doing all those, and then I got to do those diagrams, and so I was doing those, and I thought, people are going to think anything with Ethernet is going to require this redundancy in between and everything that it does between a panel and a smoke detector. So I thought, I want something to illustrate basically what I do, which is to connect panels to a computer or to off-site systems. And so that's why I thought I want to make this diagram to show when you don't have to have class N. So
just curious, what does the N stand for? Network?
Yeah, network, but it's in parallel to class A and B, are typical ways to describe fire alarm circuits that have been around for ages. And in 2010, a few more were added. So a class C for communication and a D for like a kind of a dead man type of thing. And those letters fit kind of cool. So we thought, well, and at the same time, we thought we didn't want to have like the most vigorously protected circuit historically was it was called style 7, but it's like it can survive a short and still work. And that kind of circuit is very expensive to implement. So we didn't want to make that like class AA because everybody, people have a tendency to go, well, I want the best. So, we decided to make that circuit class X to take it off the, off the grade AAA kind of mindset. So then class X means it's got that super redundancy built in that it can survive a short and still operate.
Mm-hmm.
And so we had this kind of breakout, so you no longer had just class A and B, you had these other classes. So class, picking the letter N seemed like a really good thing to us to designate that this is for networks.
Yep.
So, and do we still have much time, Mike?
Well, how do you feel? We can, I
So
think
there's
go ahead.
another concept that I kind of wanted to go over. I'll try to be quick about it here.
Sure.
Let's jump ahead here. Okay. All right. Okay.
So who are the negative votes? Are these the enforcement community? Are you finding your colleagues in the manufacturing interest? Are they
Well,
of like mind, or are they?
everybody right now, I think, is on board. I think there were a few people that were wondering, is this really going to be reliable? And, basically questioning, are we ready to do this? But at the NFPA conference, the PowerPoint that I showed is actually only going to be 15 minutes out of 5 of us that are going to be talking about Class N. So if anybody's going to be going to the conference, if that interests you at all, then that would be a really good session. It's Monday, starting at about 11 o'clock, I think.
Well, what we can do, we'll upload this on our Twitter site, and people can be aware of it. Go ahead.
Yeah. That's going to be a good conference, and what the other guys are going to be talking about, the other aspects of it, which have to do with sharing networks, and you're not going to be able to tap in at the nearest cheapest Best Buy Ethernet switch, and those guys can talk about how all that will work. So that'll be a good, but this concept of different kinds of panels, I really wanted to try to cover today, since we're talking about interoperability in panels. Here I'm listing 3 different models of fire alarm panels made by a company named, it was Fire Control Instruments back in 1991, and now it's called Gamewell FCI after some mergers and purchased by Honeywell. But back in 1987, a printout of a model FCID looked like this. It's missing, a smoke detector, and it would give the description. It's Zone 1B, Room 145, switch gear, I guess. It was an ion detector, and the address was common, so it was like smoke detector, loop 1, device number 02. And then the time and date. Then you had an alarm shown, and it would be, show you it's a duct detector, module 1, so this would be a module monitoring, and you could kind of read that through if you understood what the fire alarm panel was telling you, and find these things: condition, description, type, address. Later, they decided to rearrange all that. And so here you have, a different arrangement. The address is no longer, have a comma in it. It's similar, but different too. And then by 1993, they did things completely different, and kind of the same panel, but they just rearranged everything. And instead of those short addresses, now they have longer ones. That's like a remote display unit and analog loop unit and different words like this, that, abbreviations that tend to make it so that the guy that installed it probably understands what it all means, but, guards, not necessarily. Guards couldn't. How could they?
Well, that's why it's important for you to have had overlaid your plan views.
Yes. And but you're still dealing with these categories. I'm showing them how they're juggled all over the place. And even then you got your merger, so you got, the old game wall system did this, and then even they came to a network version, and they bumped everything down a couple lines. So, the fourth line no longer meant the description. It was now, description of the panel itself. So this is how these things can get, how it is that they are all so dysfunctional as far as being interoperable. A lot of people say that the panel manufacturers deliberately wanted it to be different from one from another. But the bottom line is they just didn't look at what the other people were doing. So there's been no standardization as to the format of these things.
Well, that cuts that cuts to one of the drivers. When we started tracking this in 2010, it was the problem of our University of Michigan security people not seeing the same thing, and the environment, the visual environment that they're working on was a challenge for them. And so that's why, again, one of the reasons why I've been following this for so long, because it is an important development and adds value to our industry at many dimensions. Go ahead, Dan.
Yep. So, yeah, that's exactly it. And the issue with these different items. Sorry, got distracted there. What is illustrated by these little boxes that I show here. Almost without knowing it, they did standardize. They have still come up with that they have a device address. Whoops, let me go there. They have a device address. They have a device type, a condition, the state that it's in. I mean, state and condition are obviously very similar, but they're you only have about 5 pieces of data, and just going back through these, you'll see that they're all the same thing. It's just that each manufacturer just formats it differently, and they may abbreviate it differently, but with my system, or with the customers that I've provided the solution for, they didn't care what any particular manufacturer called it. So I actually private label through other companies, like commercial wireless. Fike has been selling quite a few systems for a number of years. They're actually UL listed for control, to silence, acknowledge, and reset. Hochiki just got UL listed for remote control. And we have our own brand that we call Rescue Logic. And Siemens is selling it as a product called Insight Light in some areas. And, basically the idea is, I don't know if I can zoom in on this a little bit. The idea is that out of those, categories I was showing you before, by turning it into actual data, now you can do a whole bunch of stuff. You can put in a list like this with color-coded items for every condition. You can make it pinpoint an item on a map with the individual address number. That would be a unique point for every item in the system. And you can, map the building. You can send out emails, do, voice systems, generate voice messages, generate instructions on what people are supposed to do about the problem. The important thing, in my opinion, is to turn it into usable data. Those various text streams that, over the years, it takes any of us that have been around for a long time. You can read it, but it takes some work even to figure out what that must mean.
Mm-hmm. Yep.
So anyway, this says at the bottom now a demonstration, because I usually give this PowerPoint right before giving a demonstration, which I would be happy to do at any time when we have another session or whatever you'd like.
Okay. Well, that's an eyeful, so to say. I'm very gratified to see that we've been able to maintain contact with this particular issue. If you don't mind, I'm going to cut over to my screen and we can sort of wrap things up here. But in general, as I try to remind my colleagues that we're working with probably one of the best standard organizations in the country or the world, NFPA, and its partisans and friends of the NFPA are feel passionate about doing the right thing for their particular interest. But it is also possible that sometimes that we need to nudge each other along, and but we also have to have a lot of patience. And I often will tell our leadership that what we do often will take 6 to 12 years. And that's longer than all construction projects, and that's longer than the tenure of most college and university presidents. It wouldn't be a surprise to anybody to need to argue a case in front of the Supreme Court. However, a lot of these cases start, when you hear the news coverage of them, they started in 2005, and it's been on the docket, and it's taken this long to run it through the system. So in any case, that's my only way of saying that in addition to having an idea, you also have to have the patience to nurture that idea through the system. You have to be part of the system as you are on the NFPA 72 panel. And so it's really standards development is not for all markets, so to say. You really do have to sustain ideas, and you have to be able to work alone for a long time, because very often you'll confront situations where you're wondering if you're right at all, or more lately, is it important to be right? So I give you a lot of credit for nurturing these ideas through the system. And so what I'll do is cut over to my screen, and then we'll close things out a bit here. Is that anything else you want to show on your screen? Anything about your you have a bio or something, Dan, Don, that you'd like to be able to show us? What?
I found it on the website.
There you are. Good. All right.
Picture of me, and basically, I started CAD graphics, and now we call the software Rescue Logic, since we're OEMing it to other companies, and so I've been on the Protected Premises Committee since 2001, and I'm proud to have been the chair of the task group on circuits and pathways when something called the style tables got removed from the code in 2010, and we went back to our Class A and B designation. Mm-hmm. And again, I was on the Technical Correlating Committee task group on networks. Mm-hmm.
All right, so you'll be at the conference next week. That's your, and I'll identify that. I have somebody. If it's not me, I'll have somebody else tweet that out to our industry. And let's see then. All right, anything else you want us to see before we close out here, Dan?
No, that's all for me today.
Okay, good. So let's make myself the presenter. And so this is where I'll leave everyone. When we do these, this particular issue has been on our docket since 2010. If I go through, we have many documents that track what we do, but if I go way, way back to 2010, what is that, 17? Yeah, we've been working on it since then. We made some proposals for more and those proposals were rejected. And so Dan's made more progress than we have. And then I think we dealt with back in 2011. Back in 2011, I think we put some ideas on there. It was 11, 15. Okay, this is as far as we got. It was a high priority item for us, but we didn't make much progress. Maybe we're drifting off to other priorities, and then finally, I think, what else? So then more lately, we're going into it. We have a little bit more staff now to deal with some of the communications issues, so I can, and also an expanding interest in this area also. I'm really excited about where we're going next with a lot of this. I'm seeing social media as a way to, we find that a lot of people are really, many facility organizations are interacting with their membership through social media, and obviously the students, basically at some point in the future, I think cell phones will actually be an evolutionary trait. So inseparable are young people from them. So in any case, that's kind of it. I think we laid down a solid hour here, Dan, thanks to you.
All right, great.
Okay,